Hello, my name is Michael Obina, and today I'll be teaching you how to do flood vulnerability analysis using machine learning like Random Forest and Extreme Gradient Boosting on Google Colab using Python programming language. So stay with me. Alright, so in this folder, this is my Google Drive, and all my parameters are all here. I've prepared them. I've prepared my parameters and then put them in the folder. I named them flood data here and uploaded it to my Google Drive. Let me open it. You can see my variables here, my parameters, which I'll use for this flood analysis. So this is my boundary, okay, my study area boundary shapefile, and this is aspects. That's the first parameter I'll use for this study, aspects. Okay, I have curvature. They are all derived from elevation. All right, this is distance from river, distance from road. This is drainage density. And next is elevation. I have flood history here, flood history, and I have land use land cover classification. I have rainfall. These are all raster. I've prepared them. I have slope. I have soil, SPI stream power index, and topographic wetness index. Actually, I have 12 parameters which make up my x variable, and then one y variable, which is the dependent variable, which is the flood history. My flood history is the dependent variable, okay, and it's depending on 12 other variables which make up the independent variables. Okay, and these variables I got them from Google Earth Engine. Yeah, got them from Google Earth Engine, and in raster form took them to ArcGIS Pro, whereby I clipped it to my study area boundaries. Then I preprocessed them by reprojecting to UTM zone 32, yeah, because that's the projection that fits my study area. UTM Universal Transverse Mercator zone 32, and I had to reclassify to 10 meters spatial resolution, because most of them came in 30 meter spatial resolution. For example, slope, aspects, rainfall, okay, curvature, distance from road, distance from river. They all came in 30 meters spatial resolution. But the flood history, because it was captured using Sentinel-1, yeah, captured using Sentinel-1, Sentinel-1 comes in a 10 meter resolution, so I had to unify the resolution. So I had to resample the other parameters to 10 meters resolution. So these are things you do to prepare your data sets before you begin to feed them into the model. Okay, so I've prepared them. We projected it to UTM zone 32, resampled to 10 meter resolution, and then clipped to my study area boundary, and I had to upload to my Google Drive here. So from here we start building the model. All right, so the platform I'm using for this is Google Colab. Is an IDE that allows for Python programming. It allows for R. It also allows for JavaScript. Okay, but I'm going to use Python for this work. So this is it. This is what Google Colab looks like. And Yeah, this is what it looks like. So in this place, you name your, I'm actually gonna give the name. I'll name it flood analysis 5. And the beautiful part is that it's a sync to your Google Drive. So once you rename it, it automatically saves to your Google Drive and updates. So anything you do here updates to your Google Drive. Alright, so the first thing I do here, I select my runtime. I like to use GPU. Yeah, it's quite faster than CPU, and it's TPU. So anyone you want. So I'll go with this. Alright, so and then I'm set. Alright, if you're wondering how if you're new, you want to know how to get started with Google Colab, you just come over to Google search, you just type Google Colab. Alright, look at it here. So you access it, and you sign in. Of course, you have a Google account, so you sign up here. Alright, you just follow it. It's quite easy. Alright, so let's get started. So today we're going to build two models for flood vulnerability prediction and analysis, and then so let's get started. Alright, so the first thing we're going to do is to impute the code to mount our Google Drive, and this is the code here from Google.Colab, import drive.mount. Okay, so once you import this code, you click on run here. It takes some time to run, and then you get to link up your Google Drive. Yeah, so you come here, connect to Google Drive. Give it some time. It's quite easy and direct. Yeah, the account I want to link up to. Yeah, continue. Okay, read all the scroll down. I say continue. Yeah, it's actually running. Within a few seconds now, it's going to mount my Google Drive. Correct. Alright, so it says mounted at contents/drives. That means my Google Drive is mounted. Okay, so it can now access whatever I have in my Google Drive. So once you're programming and you get this good sign, yeah, that means the code ran successfully. But if it did not run successfully, you will not get this sign here. So what it means, you have to debug. Whenever you want to debug it, maybe copy your code to ChatGPT to debug and come back. Alright, so that's the first time we've mounted our Google Drive. Okay, now we have to Google Colab works with Jupyter Notebook. Okay, that's a blocks of codes that allows you for your programming. So we're going to bring in another block of code. So click on here. Yeah, good. No, so at this point we're going to import all the libraries that we need for this work. So stay with me. So this is the code we use to install some libraries we need. We need Rasterio, we need GeoPandas, we need scikit-learn, we need XGBoost, we need MATLAB plots, we need Shapely. Alright, so once we bring in this code, you now click on run. Give it some time to populate here. So they are all installed. You can see them, see the results. So correct, it was successful. So that means the basic tools that we need, libraries inside the Python, yeah, we've gotten them. So we proceed. We need some other libraries. So you click on bring in another coding block, and then we input the code. Alright, so the last step, we installed the libraries we need. Now let's import it. So we import Rasterio, import the NumPy, import MATLAB, okay, scikit-learn, XGBoost, and the rest of them. So we need to import it All right, so once you type this code, we now run it. Good, successful. All right, successful. So we proceed, bring in another coding block and type the next code. All right, so the next code is for us to give our programming access to our Google Drive address, the folder where our data sets were saved. Okay, and this is the address here. Remember, we initially mounted our drive, so this is the address to where our data sets are saved inside our folder. Okay, so this is the command. Okay, and these are the data sets. Remember our x variable, our independent variable: elevation, slope, curvature, aspects, rainfall, land use, land cover, soil, SPI, TWI, distance from row, distance from, and then the way you name it in your Google Drive. Okay, ensure that it is the same here, no errors, and then for it to run successfully. So this is our independent variable, and this is the target file. That's our dependent variable. That's a flood history. All right, so the code is quite long and I'm going to take you through it. So where is it? I'm going to give you I'm going to drop the link to this code. All right, so you can have access to it. So ensure that everything is okay. All right, everything is okay. So now we run it. Correct. So it was quite successful. It has had access to our data sets in the folder, and these are the results. It was able to read elevation, slope, was able to read everything. Okay, it also resampled it, and everything was successful. So we can proceed to the next step by bringing in another code block, and then we proceed with the code. Alright, so the next line of code is for us to resample our data sets. The data sets we imported earlier, we have to resample to ensure that they both align, all of them align. Okay, and then we're going to use the reference data set elevation. So we resample, we also stack. We resample it, we also stack them. So, and that's what all these codes are telling us about. We sample, we also stack, you load them, okay, and then you stack them. Okay, so so we run the code, correct. So it was quite successful. About getting to the point where we get to build our model, trying to fine-tune the data sets so that there will be no issues. So correct, it says everything was successfully read and resampled. So we'll bring in the next coding block so we can proceed. Alright, so this next line of code is further fine-tuning of our data sets to remove non-values. Okay, rows with non-values and things like that, trying to remove rows with none, okay, in the feature or target. Okay, and this is the code to further clean it up so that for seamless model training, and so we run it. So it was quite successful. That was quite fast. So we bring another coding block and proceed. Alright, so this code is used to train the model. Okay, it's an initial instruction to tell the model to use 30%, 0.3% of our y variable. Okay, or y variable, that's the dependent variable, use 30% of it, reserve 30% of it for testing. What it means is that the model is to use 70% to train the model, and after training it, 30% will be reserved for testing it. Okay, so which we use for the 2 random seeds. Alright, so that's what this code does. So let's run it. That was quite successful and fast. Okay, let's bring in another code block and proceed. Okay, at this point, this is where we train our random forest model. We'll train random forest first before extreme graded boost model. So in this model, we are using we're going to use 100 decision trees to train this model. 100 decision trees to train this model. Okay, so and this is the code. 42 random seeds. All right, so this is the code. All right, so we're going to proceed and run it. All right, perfect. Our random forest model has been built. You can see it was successful. All right, it was successful. So let's bring another code block and proceed to building our extreme graded boost model. Alright, this is the code to build our extreme graded boosting model. You can see it, XGB classifier. Alright, so the same 100 decision trees we'll still use to build this, but it's still random states, and to build this model. So let's run it. Perfect. So our extreme graded boosting model has been built. That was quite fast. So the next thing to do is to run our accuracy checks, accuracy validations, rock AUC, and the other tests. From there, we get our feature importance, which of the parameters rank highest, from highest to lowest, in influencing flooding in the study area. So we'll go ahead, bring in another code block, and then start the code. Stay with me. Alright, so this code will give us the confusion matrix, it will give us the accuracy, it will give us the rock AUC scores, alright, for both models that we built. Okay, so let's run it. Perfect. Alright, so let us check the results. Very good, very good. You can see the confusion matrix for the random forest, see the precision, see the recall value, see the F1 scores. Okay, and I see the accuracy for random forest 0.98 and the rock value 0.97. so accuracy 98%. It accurately predicted flooding in the area. Okay, and in the rock value 97%, 0.97. Okay, let us see for that of extreme graded boost. Okay, that's the confusion matrix for extreme gradient boost, and then that's the precision value, recall value, F1 score. Okay, alright, let's see the accuracy and rock value. Accuracy of extreme gradient boost 0.98, that's 98%, the same with random forest, but something happened in rock AUC 0.90. A lot of empirical studies have shown that the accuracy, the rock AUC value for random forest is usually high for random forest than extreme gradient boost, and this seems to comply with that. Okay, that's good. So the next thing we do, we proceed to get our feature importance. Okay, feature importance, which of the parameters influence flooding in the study area more than the other. So bring in the coding block and then we'll proceed. This set of code will give us the rock AUC curve for random forest and extreme gradient boost. Okay, let's run. Successful. So let us see it. Perfect. That's the rock curve, and that's the rock AEC value for Random Forest 0.97, for XGBoost 0.91. Okay, perfect. So let's proceed and get our feature importance. Our feature importance charts. Alright, so this set of code will help us get our feature importance. Okay, we need MATLAB, so we import it. Okay, we need NumPy. Alright, okay, so and this is for the Random Forest. Okay, trying to get the feature importance, you plot it and all that, and that's the way it should be saved in our Google Drive, saved as a PNG in our Google Drive. Okay, let me scroll down for you to see the rest of the code, and then we'll proceed to that of the extreme gradient boost. Alright, this is the prediction code. Alright, so and then this is where it will be saved in the Google Drive. So once you're satisfied with this code, you run. I hope there will be no errors. Let's run and see. Perfect. Okay, our Google code was successful. Alright, so that is it. This for extreme gradient, this for Random Forest. For Random Forest, rainfall seems to be the most influencing factors in the study area. You can see rainfall, that's the bar chart for rainfall, followed by distance from river. Talking about factors influencing flooding in our study area. Then curvature is next, and then distance from road, TWI, and then followed by SPI, and then aspects. Before you get elevation, drainage density, slope, and the least is the soil. So what it means is that soil has the least, effects in influencing flooding in the study area, and this is the feature importance for extreme gradient boosts. So in this one, let's see what has the highest influencing power. Okay, it tells us that land use and cover has the highest influence in causing flooding in the area. Okay, and the rest are quite minimal. The rest of the factors are quite minimal. Okay. Alright, so with this we have learned how to build a Random Forest and extreme gradient boost model in predicting flood vulnerability in a study area. Okay, using Google Colab, actually Python programming language. We built the model, we saw the accuracy validation, and then we got the feature importance. Alright, so if you want me to teach you how to prepare your data sets, your elevation, your flood history, your slope, the rest of them, the parameters, leave me a comment in the comment section, and then I will do another video detailing how each of those parameters were prepared, okay, reprojected, and then resampled to ensure that they all have uniform spatial resolution. So leave me a comment, and also follow this channel, subscribe to this channel to encourage us to make more of these videos. Alright, so leave me a comment if you want me to show you how to prepare those data sets. Alright, so the next thing is how to get our flood risk map. So that will be in the next video. So leave me a comment, like, share, and subscribe. Thank you for now.